assume that. And at the moment, if you look at the relative motion of all the stars and galaxies, they seem to be it seems to be like there's this missing mass where you'd have to add this mass for the motion that we have to make any kind of sense. And so they sort of went looking for it. And when I was in grad school, I think they thought it was like the mass of one of the neutrinos was all the missing mass. It turned out to not be the case. And um, I'm trying to remember. There's a number of candidates that keep getting knocked down. And so help me if there was one that was proven to be it. It's not my fault. I haven't looked at it in a while. But again, that's to resolve a fundamental conflict, which is if I look at all the luminous matter, what I think is all the non-luminous matter in the universe, and then I look at the like accelerate relative acceleration of everything, it looks like there's missing stuff. And it could be a lot of things. Um, if I pick something out of the hat, I say, no, it's not missing matter. It's a second order term in the gravitational or something. It's like, well, there's a there's another term where gravity isn't just like one over r squared, and it doesn't just pull like that. There's also a really long range one that only sort of turns on at a really gigantic distance, um, and that has to be added into, and that would fix it as well. And so people would say, like, that's a very classic physics thing to do. Somebody goes, "Yeah, my cosmology is broken. All the relative motions of things aren't quite right, and I don't know what would make that happen." And a theorist will go, "Ah, I know. If I added another thing onto gravity that basically turns on at a long distance, maybe that would fix it." And then that becomes a standing hypothesis until somebody knocks it down. They go, "Okay, well, how are we going to test that?"